Good morning, everyone. I am Ravina Tandekar. Today we will discuss about the graph algorithm in AI. Let's start. Graph definitions of graph related concepts. A graph is a finite set of nodes with edges between nodes. Okay. Formally, a graph G, capital G, is a structure V and E consisting of a finite set of we called the set of nodes and a set E that is a subset of Vx. V equals to, so let's start as we will discuss example of a graph. V is a subset of 0, 1, 2, 3 and 4 is pairs of 0, 1, 1, 2, 0, 3, 3, 0, 2, 2 and 4, 3. When x and y is edges, we say that x is adjacent to y and y is the adjacent from x. So 0 is adjacent to 1 and 1 is adjacent to 0. A real life example of graph. V equals to set of 6 peoples like John, Mary, Joy, Helen, Tom and Paul of age 12, 15, 12, 15 and 13 and 13 respectively. Okay. So E is equals to X and Y if X younger than Y. X younger than Y. The code represent entities such as the people, cities, computers, words, etc. Graph representation. For a graph to be computationally useful, they have to be conventionally represented in a programs. There are two computers represented of graphs: adjacency matrix representation and adjacency leads representations. So adjacency matrix representation is in this representation, each graph of nodes is represented by an x and matrix A, capital A. That is a two-dimensional array A. The nodes are re-labeled 1 to n. A of I and j equals to 1 if I and j is an edge. Example of adjacency matrix: A equals to, suppose this matrix 0, 1, 0, 1, 0, like that. Another example, adjacency matrix: relabel the nodes with numerical labels. Then pros and cons of adjacency matrices. Pros means simple to implement and easy, fast to tell if a pair ij is an edge. Simply check if A of aij is a 1 or 0. Cons means no matter how few edge the graph has, the matrix takes of n square is a memory. Then adjacency leads representation. A graph of n nodes is represented by a one-dimensional array L of linked list, where L of I is the linked list consisting all the nodes adjacent from a nodes. The nodes is the list L of I are in a no particular order. Example of link representation: L0 is empty. That is Mary, 0, Helen, John, Joel, Tom, Paul. These are the examples. L0 empty, L1 is empty. L2 is 0, 1, 4, 5. Then L3 is 0, 1, 4, 5. L4 is 0, 1. L5 is 0, 1. Graph class. Uh, this is the graph class. Public type def in data type. Then type def data type pointers we represent as pointer. Graph int a equals to 0. Graph class representation. This is the form of graph class representation. Graph init insert n is greater than equals to 0. Number of nodes equals to n. If n equals to 0, then p equals to null. Else, otherwise, p equals to new data type of n for loop int I equals to 0, I is less than n, then I plus plus. P of I equals to new data type of n for int j equals to 0, j is less than n, j plus plus. Then P of I j equals to 0. Next, directed versus undirected graph. What is directed graph? Basically, if the directed of the edges matters, then we show the edge directions. And the graph is called a degree directed graph or a graph diagram. The previous two examples are digraph. If the relationship represented by the edges are symmetric, such as x and y is edges, if and only if x is a subline of y, then we don't show the directions of the edges, and the graph is called undirected. This is the example of undirected graph. Capital V is set for 6 people: John, Mary, Joy, Helen, Tom, and Paul, where the first 4 siblings and the last 2 are siblings. 2 are siblings equals to x, y. X and y are siblings. Then representation of undirected graph. Undirected means the same two representation for directed graph can be used for undirected graphs. Adjacent matrices A of ij equals to 1. If I and j is an edge, this is 0. Otherwise, adjacent list Li is the linked list containing all the neighbors of I. This is the example of representations. Linked list L0 is 1, 2, 3. Then L1 0, 1, 2, 3. L2 is 0, 1, 3. Then L3 is 0, 1, 2. L4 is 5. And L5 is 4. Definitions of some graphs related concept. Let capital G be a directed graph. The in degree of nodes. X is a G is the number of edges containing of X. So the out degree of X is the number of edges leaving X. Let capital B is an undirected graph. Things for you do. Add a number functions to the class graph called gentle degree, get degree, in degree, get degree in X, which returns the in degree of node X. Add a number function to the class graph called get out degree in X, which returns the out degree of node X.